Hi, everyone. Hi, everyone. I'm Jing from Dataris. Um, my presentations, I'll give two use cases where we apply AI techniques in the river basin Rhine. One case is about low flow forecasting, and the other case is about flood risk management. Wait. Okay, great. The Rhine Basin, for those who are not familiar with, it has an area of over 180,000 square cubic meters. And the rivers originate from the Alpine regions and flow all the way through Germany and Luxembourg, and then down to the Netherlands and flow to the North Sea. The Rhine enters Netherlands at the point of Lobith. Usually at the flow at Lobith, usually it has a quite low discharge during the summer and the autumn times, and it's quite high in the winter times. Extreme conditions for floods, the discharge can be above like 10,000 cubic meters per second, and extreme low flow conditions can be below like 1,000 cubic meters per second. Just give you an idea of what kind of basin and flow it is. No. Next. Oh, it's not moving. Okay, it worked. So the first case is about using machine learning model to help with low flow forecasting. This is a research study. In this study, we develop a novel LSTM-based model to leverage both historical observations and forecasted meteorology data to help predict low flows at Lobith for 46 days ahead. And the trained model was tested using Aaron Cisno 5 datasets with ensemble members. An example forecast from the model, as you can see on your right side, this is the rate forecast for the low flow events in 2018 August. You can see the gray spaghettis are the ensemble forecasts, and the blue lines are the observations. The model performed quite well, and in this low flow condition, start with a quite right initial condition and also a nice spread along the lead times. In this study, we also explored to use explainable AI techniques to help modelers ourselves to better understand why the model behaved like this, why the model gave the results. We really found that these techniques, one, help developers to understand how different features contribute to the results, to see if it's really aligned with our physics understanding of the system. On the other hand, we feel like, or we found that explainable AI techniques really help to open a way to involve stakeholders or non-AI experts or end users, to involve them in the model development phase, and for them to understand why the model behaved like this, why it gave the certain results instead of the others. Kind of a way, provide a way to build more trust on the end users in the model itself. Uncertainty is also important, not only around physics-based model, but also for machine learning model. You can imagine because of the training data and because of the training strategy, and the trained machine learning model itself can have a lot of uncertainty, and how to address this uncertainty in your forecast results. In this study, we explored using conformal prediction to address the uncertainty in the model, and combine with weather uncertainties to provide better decision making. That's the first case. And the second use case is where we explore using large language models to help create a flood measures inventory. So for flood risk management, especially in large river basins, usually involve a lot of authorities, competent authorities from different levels, national level, regional or local, and cross-boundary. And usually normally there's no complete overview of the flood measures taken or planned by different parties. But this overview can be very useful and important for people to do flood risk assessments. So in this project, we aim to explore how we can leverage large language model to help us provide these inventories. So in this project, we explore two parts that the language model can help. One part is that we use language model to help us do data mining and processing. You can imagine like we have tons of great documents from the internet or websites. We use language model to help us extract information about authorities, about the flood measures taken and planned by the authorities, and about to ask the model to retrieve and clip the geospatial data sets around the area of interest, to help us prepare this database. So later on we can have a look, or you can analyze, or have a look or interact. And the second part is that we, after we have the database, we have to, as I said, we have to analyze it, we have to look into it and to see what kind of knowledge we can get from out of it. So we develop a very simple web UI where we allow users to interact with the database and knowledge of from the documents through chat. This is a screenshot of the prototype for the web UI, where you can see on the main map you can show different kinds of database, for instance, authority database that we prepared, flood measures database. You can also show other geospatial data like river networks and other spatial data of interest. And in the right hand, you have the chats, where it has, besides general chat functions, we also develop specific functionalities for for different user stories and needs. A few examples. One user might want to do some simple statistic analysis, or plot some graphs for the database. So they maybe they can just type in the question like, what kind of flood measures are in the area in Netherlands, for instance. And the second use need or a story can be that the user want to ask more general questions like, what kind of what's the current flood risk management plans in Belgium, in the Rhine part, for instance. And then the large language model, together with other advanced large language model techniques like RAG, it will be augmented by the knowledge from domain knowledge from the documentations, to help with the responses that give to the user. Other use cases about reporting, you probably want to create a quick fact sheet or memo of your area of interest when you zoom in. So there are different possibilities and different user stories and needs. We're still developing for this simple applications. So that's from my side. Very looking forward to your questions or discussions in the afternoon. And if you want to know more about it, just feel free to reach out. Thank you.